Hello, dear participants. Good evening, one and all. We have our speakers with us, Mr. Akshat Dikshit and Sai Kunduri. I hand over the sessions to the trainers. Thank you.
Hey, hi, thanks. Hello, are you able to hear me?
Yeah,
Yes,
Sai,
you
you
are
are
audible.
audible.
Yeah. So, myself, Sai Kanjuri. I work for IBM ISL Labs as a senior software developer. My day job is to develop smart contracts and deliver it to the clients as per the requirements. So, I have Akshat with me, and he's the lead of our blockchain solutions team, and he has extensive experience on blockchain platform. Over to you, Akshat. You can start the session. We'll
Hey
take off
guys.
from there. Yeah.
Hey, thanks. Hello everyone. Yeah, so let me quickly share the screen and then we'll start. All right. Can you guys see my screen? Anybody?
Yes, it is
Yeah,
visible.
it is visible.
All right. Thank you. Okay. So we're going to go over the smart contracts, which is the fundamental block of any blockchain solution. Smart contract is something where where all your logic, all your business logic resides, right? So me and my colleague Sai, will take you over some of the basic things. The agenda for today's session would be to explain what is the life cycle of a smart contract or a chain code, right? How, and we will go over, we have a sample application. We will go over that code. We'll, tell you what is the, how you can build a sample application, a sample smart contract, how you can install and instantiate your contracts or chain codes on a local network, right, for testing, doing your POCs, whatever. How do you invoke your smart contracts? What are the basic fundamental methods that are in the smart contract that you should know about? And some of the common features, common not the features, but common bottlenecks or issues that we have encountered, us working on blockchain and writing smart contracts, right? Okay. So let's start with the fundamentals, right? What is a smart contract? So there are two things here, right? So there is a smart contract and then there is a chain code, right? So what is the difference between the two, right? So when you go over Hyperledger Fabric, right, or any other blockchain provider, right, you will encounter these two acronyms, right? And not the acronym, but very frequently used terms, right? A smart contract and a chain code, right? So a smart contract uh, is something, is the code where your business logic lies, right? It is the actual piece of code or the logic which does the transaction, right? Even the hello world, right? If you write a hello world, you have a print statement, right? So that uh, is your actual smart contract, right? Which is doing something. It could be a get operation, put operation, or something. It could be computing. It could be calculating. Anything which is related to your business logic is your smart contract. A chain code is you can consider a package or a wrapper of all your smart contracts, right? That you want to bundle and deploy, right? So a chain code can contain multiple smart contracts, right? So let's say you have a application, an insurance application, right? So you have insurance for vehicle insurance, or a life insurance, right? Or a property insurance. All these are separate smart contracts, but you can bundle them into a single package when you are going to deploy, right? So once you deploy, all your individual smart contracts come into play, right? So you can invoke each of them individually, separately, right? Each of them would have their own functioning, right? So there will not be any I mean, it depends on your business logic, to be fair, right? But you can call them independently from your application, right? So that is a basic difference between a chain code and a smart contract. Okay, coming to the chain code, right? So let's talk about the chain code first, and then we will come to smart contract. So a chain code, the uh, the phases of a chain code are, first it is, there's a packaging of the smart contract. So you package all your smart contracts into a bundle, right? Generally, it is a tar gz file, which is uh, also denoted as a .cds file, right? You bundle all your smart contracts in packages, and then comes the second step, where you install your smart contract on your peers, right? So the first image that you see here, you have a network, right? A network with two orgs, org1 and org2. Each org has two peers, right? Peer 1, peer 2, right? So on a network, essentially there are four peers, right? So you bundle your smart contract, you get a chain code, and now you have to install your chain code so that your business applications can start using it, right? So what you do is you take that smart contract and you deploy them or install them individually on all four peers, right? So there will be a separate copy deployed on all four peers individually, right? That is what is meant by install. Then comes instantiation, right? You instantiate a chain code, right? We don't instantiate a smart contract, we instantiate a chain code, right? So once you instantiate a chain code, all your smart contracts, which you can also, if you want to visualize them, it could be separate methods inside your chain code, right? All your smart contracts are exposed, right? Or they can be invoked by your application using a SDK, right? The instantiation of a chain code is a bit different than installing, right? So we install the chain code on peers, right? So installation is per peer, right? Whereas instantiation is per channel, right? So we instantiate a chain code on a channel, right? So once we instantiate, it is another transaction that happens on the network, and once it happens on a peer, right? So it could be done on any one of these four peers, right? So we have a channel here which connects all four peers, right? So we instantiate the smart contract on any one of the peer, and it goes as a transaction to all four the peers, and it is instantiated. So essentially the chain code is instantiated, meaning that any of the smart contracts inside it is now visible and can be accessed by the application layer, right? So depending on your network architecture, your channel architecture, you will want to install the chain codes appropriately on the peers and instantiate them on the channels, as per your business requirement. All right. Okay. So smart contract, right? So I'll let Sai take over from here and explain more on the smart contract.
Sure, Akshat. Thank you. So, yeah, as explained, that a chain code is a package of smart contracts. Now, this is you can think the smart contract is a minute part of the chain code. Now, I'm taking you through the smart contract, how it does look and how the applications actually can interact with the smart contract. So in this image, you can see like how this is the application layer. You can think this as a simple client and server architecture, where a client requires if you taking this to the anomaly of normal server and client and requesting data from the server. So this is a client application. It will be interacting using a SDK with the blockchain platform. So this is the blockchain network. It will be interacting using this client SDK. This client SDK can be a Java based or Node based or Go based. Currently, Hyperledger Fabric has the support for these three. So you can use any SDK and you can interact with the smart contract. Okay, so the smart contract now it comes into the basic functionalities provided by the like for any database. If you are talking from any normal NoSQL DB or SQL DB, what are the basic functionalities we will have? Retrieval, that is using the get operation, and there are put operations where you can do the insertion and updation, and then we have a delete operation which deletes. Now you can visualize this anomaly of normal database to the ledger in the blockchain. So this is your world state or else the ledger. Okay. So the smart contract, using the smart contract, you can perform the get, put and delete operations and it will be recorded on the chain. So how you can, this is different from your normal um, normal SQL DB, you may ask. Here also we are doing get and put, there also we do. But how this is different from the actual SQL operations. So here the only thing here is like when you are, this is a decentralized. That means you will have every peer will have, first whenever you are querying, there are two kinds of operations here. There is a query operation that is nothing but the get operation. And the second one is the submit kind of submit proposal operation. Submit in the sense that's where exactly the block addition will happen to the ledger. So when a query operation is made, it will be made to the means based on your application design, you can make the query to all the pairs and get the proposals and compare it, or otherwise you can query any pair at a time and get the response back from that. So, but that is not the same with the actual put transaction, that is submitting the transaction. The submitting the transaction is again into two parts. It is the sending the transaction for approval. Then once after you get the proposal back, then again you will submit it to the orderer. So that means to say that it is the two phase. The first phase is just asking it, shall I see, this is the thing. You will be invoking some method in the smart contract and you will say like, I want to add this particular data onto my ledger. Then your smart contract executes. Then it will send out a response, that is invoke, and then you will give it a response. That response is nothing but the proposal response. So the proposal response will be driven back to the application, and then application again does the submitting. The submit will go to the orderer. So the orderer in the blockchain network, it has to do the consensus based on your consensus algorithm, and it will approve, and then finally it will get added back to your ledger. So it will have all the history. So each block it gets added will have the hash of the previous block. So at any point of time, it is crisp, transparent for you, that the history of your particular transaction defines that you can actually replicate everything. That means to say from starting to ending, you can see all the transaction made on a particular key in the sense here you can think that in a normal SQL DB as a ID. So on particular key, how what all that happens, it will you can be tracing back it. So now I will be showing you the code of one of the smart contract which we have written, smart contract. So this is a account detail smart contract. This is something which you are all aware of. So I have taken this as the example, and it's been written on Hyperledger 1.6. So the latest version is 2. It is available, but this is based on 1.4.6. You can there is no much difference in the way how the code will be in 2 and 1.4.6. It is almost the same, except the way how you are responding back. Yeah. So now I'll compare the smart contract lifecycle. This is the init method. So
Sai,
this is
hey, Sai, you,
yeah.
are you sharing your screen?
Yes.
I think I
Uh,
need to stop and then you need to share.
yeah. Yes. Sure.
Yeah, yeah. Could you share now?
Yes.
I think you will have to go back 30 seconds.
Yes. No, actually, it is asking me to rejoin.
No, I think you can deny, you can say later, kind of a thing.
Uh, okay. Are you able to see my screen by any chance?
No, not yet.
Um, no, it is not allowing me to share the screen. It is saying accessibility. I think I need to give it. Just hold on. Oh God. What is
It's okay, Sai, you can rejoin. I'll take up any questions if there are.
It is asking me to rejoin, otherwise it can't take the changes it says. So let me rejoin.
Okay, sure.
Yeah.
Okay, if you guys have any questions till now, I'll be happy to take them. Hey, Devjani, could you make Sai the co-host? I think she's not able to share the screen or unmute herself.
Yeah, thanks, Devyani. So can I share my screen?
Yeah, sure, go
It
ahead.
says again, host disabled participant screen sharing. I believe, Devyani, you have to make me co-host.
Hey, Devjani, we need your help here.
Hey, can you please give me the access also for sharing the screen, Devyani? Host disabled participant screen sharing. Akshat, just see in the participant if you can give me a co-host thing, you can make me.
Yeah. Okay,
Yes,
can
I
you?
got that.
Okay.
Now I got it. Okay, guys, sorry for this technical glitch. Okay. Yeah, this is the small smart contract I have written for this account detail smart contract. So what does this basically do is it just adds the details of the account holder to the ledger. Just I have taken a typical banking example where a customer ID will be there and the customer can have multiple accounts. So this is the typical case we have taken, and this is the chain codes. Yeah. So the main, as I have explained in the slide, the entry point to that is uh, init. So the init method is the where exactly when you install and instantiate, you can optionally call this init method, which will execute the prerequisites for you, like setting the logging levels or writing some of the configurations to your ledger or initializing some of the variables which you would require further when you are processing your contracts. All those things you can do in it, your init. So there is a invoke one. Invoke is the entry point for all your subsequent requests. For example, whenever a application makes a call to execute one of the business logic or the method which you have exposed, then the call enters this invoke, and where you can write multiple functions, like each function here in I have chosen go. So each function, or it translates to a method if you are writing it in Java, each method whatever you are exposing as part of this invoke will be exposed or will be able to accessible by the application layer. So here I have added three methods. One is add and getting the details and getting all account details pertaining to a customer ID. So, and this is the start method where you have uh, this is the start method or the main method where exactly when you say like shim dot start, it will when it is invoking, when it is instantiating for the first time, it will brings up the container. So this is where it exactly brings up the container, and this will be available for the transactions. So I'm using IBP extension v2 to test instantiate and invoking all these methods, but you can use the Fabric's default first network or sample network. It has Fabric comes with the first network in 2.0 onwards, where you, and in 1.6 also you have the sample network or something where you can use that, you can explore that, and where you can bring up your own containers and through command line you can invoke the chain code. So that is also there, but IBP comes up with a extension, IBP extension, and that you can use for VS Code. So seamlessly the boilerplate of bringing up your containers or setting up your network is taken care by the IBP extension, and it is very easy for you to use. So uh, for getting started, you can use this IBP extension and do that. So, okay. Here, I will just go through each one of these methods, which what does it do? So add, get, and get all. So here I am have written a add details, which basically takes the input from the application or from the user. It adds the data to the ledger. So how it adds the data to the ledger is put state. So when I say put state, it is the putting the like put is nothing but inserting the data to the ledger with the key and value. So you can use either couch or level DB for your local networks, or you can based on your users. Here I'm using, it is by default it uses Fabric uses level DB. If you want, you can use couch also. So everything in the level DB is maintained as a key value pair. So the way how you write or how you design your keys is the way how efficiently you can search for. This is similar to a dictionary in Python or hash maps in your Java. So the key whichever comes with the in your hash map does no like it doesn't do any magics, right? It is just like key and value pair. But if you are using a couch, you can have a different way of having keys so that you can perform some selector operations and all. But level DB is like a pure key value pair. So the way how you write a key is the it defines your the performance, the efficiency of your smart contract. So here one of the example I have taken here is like this is my account details. In fact, only this much will not be there, it will be more, but just for example I have taken account number, customer ID, and customer name. So in general, one customer can have multiple accounts. For example, if you are going for any online banking like Citibank, if you have savings account, credit account, demat account, wealth account, so many accounts will be there mapped to your single customer ID. So they will be uniquely identifying a customer with a customer ID and map all the accounts to that customer. So basically, if you want to see your home page where a query you want to make to your database, like how we will make select star from your database with where the customer ID is so and so. So the similar way you have to make on a key value pair. So if you are using a basic dictionary kind of thing, it is very difficult for us to find out if you are not forming your key properly, then you have to go and find out all the records from your map and a dictionary. Then you have to check if this exists in your key. If so, add it. But how we can do efficiently by doing that is we can have some kind of object identifiers or object keys, which clearly says my key for particular type of accounts or for particular type of data, I will start with this as a prefix. My key will have this prefix. So I have created a prefix. Object type, account type is A underscore D. Simply I have given this. You can give anything. This is the convention generally we follow. And always remember that the object the type of the key or the key whatever you are forming, don't span it so huge keys, because ultimately this goes and sits on the ledger, and when it sits on the ledger, that is nothing but your memory space, and you should not waste too much for your own conventions, just to make it readable. So we should keep in our mind while framing the prefixes that it should be as small as possible but as symbolic as possible. That means I am talking about account, so I started my keys with A underscore D. This is one way of grouping the similar type of data in your hash map to fall under one umbrella. Okay. So next then comes to the part of the thing. Then what is common across my all accounts? Here we have to do the entity mapping. That means how the accounts are related to the customer. So I have n accounts which are mapped to my customer. So customer is my unique. So I can, if I get my customer ID, then I will be able to reach my account number. But if I get my account number, again tracing back, it will be little difficult because it is n to 1, right? So n accounts are mapped to one customer. So what I have done, I have taken the customer ID as part of my key. Okay. And then I have added the account number. So my unique key on the ledger, how it looks is, if I have a customer ABC, his its ID is like cus123. In that case, then uh, how it looks like is A underscore D. Yeah, here you can see, right? Account number is 1234. I gave customer ID 123 and customer name is ABC. For the other record, I have given account number is 345. Customer again remains same and customer name is ABC. Then what happens? So the key will look like A underscore D, and it takes the customer ID as the first part of the key, and the second part of the key will be account 1234. So to uniquely identify one row in my ledger, or else one row if you talk it from your uh, SQL DB, it will be combination of A underscore D, your customer ID, and then your account number. So by doing this, what is the use I will get? I can make a partial search in the sense I can say like, get me all the accounts of the type A underscore D, which all starts with this, which are all savings type account. A underscore D is my savings account. So get all the records starting with this. Or I can tell like, get all the records starts with A underscore D and map it to a particular customer ID. By doing that, the always remember the key search is in a progressive, that is nothing but will be forward search. It will search first your complex key, then your first partial key and second partial key. It cannot be right. I will give star here and then I will search with this. That is not possible. You cannot do the intermediate wildcard search because this is more or less similar like your hash map search. It has to be always a progressive search. That is nothing but first partial key cannot be a wildcard and then you cannot do. But you can always do a wildcard search at the last composite key. So this is how there are few methods. The every method means to write a smart contract, everything should implement the shim interface, which is in case of Java. And in Go, there is a concept of having interfaces, but it is not same as OOPS interface kind. In Go, if you are not familiar, the way how it should be is it has to just implement the methods defined in that. So I will just show this is the chain code stub interface. And if you are implementing this interface, you should have the methods of this interface implemented. Okay. So just if you write init and invoke, and if you say that takes the exact arguments, then it automatically understood that you have implemented the interface. In Java, you all know that it implements interface. It will identify that it is a smart contract and will pick up all the methods, whatever you implemented. So similarly, this here in the stub, so you will be the one point to your ledger communication is the stub. So you will be doing all the put and get. Imagine this stub as you can simulate this to the connection object, whatever you will be doing in your SQL operations, right? Everything you will be doing on your connection operations using taking that and perform the operations on it, DB connection. Similarly, here also everything you will be performing on this stub. So this is one this smart contract has one method which does the addition of details to the ledger, and it is doing the stub dot put state, that is nothing but adding data to the ledger. And the how it is adding, I'm just putting the key whatever I have formed, and value is the whatever the user has given. So that basically adds the data to the ledger. So I have written two methods. Two methods is get details and get all details. Okay. So get details is a definitive search. That is nothing but you are searching for the exact key, exact match on your ledger. That means your key is a complex key because I have three parts in it, and all the three parts I'm supplying and I'm getting it. So that is called the get state. When you know exactly the complete key, the definitive search it can be done by get state. It get state when you do it just exact matches the key and get it from the ledger. Like how you do on your dictionary or hash map, when you say access this particular element with this key, it does the exact match and it will give it to you. So this is the get details does that exact match. Whereas this get all account details is one more method where we are doing the get state by partial composite key. That means to say what I am doing is here. So get all the accounts which starts with A and D, A underscore D, but then get all with this customer ID. So customer ID only I'm giving. I'm not giving any of the account numbers. So partial part of the key only is matched and get me all the things. So I will just invoke these to show you how exactly the output looks, and it will be more elaborative in that manner. Okay, coming back to this. So this IBP extension has a smart contracts tab where you can see there like what all the smart contracts packaged, and this is the way how you will package, and this is the version. First part of the thing is called the name of the smart contract and at the rate, and you will give the version of the smart contract. And there is a limit that your smart contract should be below 25 MB in case of if you are using IBP, or most of the any of the platforms if you are using it may have the file size limits. So you can see that the second part is version and it can be incremental. It is incremental. Generally, versioning will be always incremental. And why this versioning is required is when you are installing and instantiating a smart contract on your when you are installing on your peer, it looks for the smart contract name and its version, whether it is already available. If it is available, it won't again take this package and upload it. What it will do is if you are incrementing, then it is nothing but if you it is like if it exists it remains, if it doesn't exist then it will take that and the that it will be available, the definition will be made available for the installation and instantiation. So this is the thing. So that's the reason why here how you can package the smart contract. So there are command tools available for you like peer life. If you are using Fabric Network, there are peer commands where peer life cycle manager package is there where it does the packaging for you. This is the part of the chain code thing. The first part is the packaging. So it is here you can see the option package the open project. So whatever open project is there, we can actually package it. So I can give details. I'm giving account details hyphen cc. So it is asking for the version. I am saying like 1.0.2. Just I'm incrementing it. So this is also when it packages, this version will be available. Basically, it is nothing but compressing, and it is like a tar zip version is compressed, right? The similar way it packaged it. So this is the Fabric environment. So if you are using First Network, this part of the work to get your environment up, you have to go to your Fabric samples, and there you have to start network.sh. There will be one start network where it brings up the network, first network for you. where you will be asked to give your channel name, everything. But here you can actually create network. Here there are options. You can tear down the here tear down is for deleting the network. Restart, stop. But you can, when you are seeing for the first time, there will be a plus button here, similar to this instantiate, where it will ask that to create the network. I gave my dev as that. That's the reason why. These are the smart contracts. So these are the smart contracts, and you can see the one of the stage which Akshat has explained. This is the installing of the smart contract, and this is for instantiating the smart contract. If you install the smart contract, that is not enough for your application layer to access your smart contracts. You have to instantiate it. Instantiating it on a channel. Channel is nothing but, and think it as a logical partition for your data. So if you can have here I have created one of the channel, my channel. So this channel and all these things are by default. If you can change it by giving organizations, if you can configure it when it asks for I want two peers, so two organizations, all the configuration options will be given by the VS Code when you are doing it for the first time. Here you can see I have created a channel, and install will be on the peer and instantiation will be per channel. Okay. So I have done when you click on this install, here the options will be coming. So it is asking which one you have to install. You can take this. So this is the console where you can find actually when it is installing, what are the logs available and all. So actually this is instantiate. So I will show you. Once after it is installed, you can see that account details v102. So I can show you one more thing here. So command palette, this is the one. Now there is an option for you to submit the transaction. So when you ask for submitting the transaction, it will show the transaction, the chain codes available. That is nothing but the smart contracts available for you to invoke the transaction on. As you can see here, V0 is not available because I haven't instantiated that on my channel. So it is not available for the invoking any transactions. If you instantiate, then it will be available. Okay. So now I am selecting this, then which function to call. Which function to call is the thing. So what are the functions I have exposed under invoke? So I can see add, get all. So I'm doing add. So I'm saying I want to invoke add. Now it is asking me what are the arguments you want to pass. So I have already taken the JSON format. So I'm just pasting it. So wait, let me do 1, 2, 3, 4, 6, 7, 5. I just changed my account with the same customer because it already exists on the ledger. So I'm giving the payload, and there is one other way also where you can pass the dynamic payload. I will come back to that. So what is the transient data? Transient data you can pass if you have like it is also a key value pair. You can pass that transient data, which will not be part of the ledger, but you can pass that will be useful for your processing of smart contract. Remember that transient data will not go and sit on ledger. So this I have invoked. So it is saying that submitting the transaction. You can see it has added. So you can see the information here. It says like it has submitted the transaction on my channel. So it has invoked this transaction on a particular channel, and then it has successfully inserted this data onto the ledger. Okay. Now it has invoked, it has instantiated, and it went in. Now I want to see the data. There are the two ways I said, right? Now two methods I am exposed. One is the get method and the other one is the get all. So when I say get, I told you, right? It is a definitive search. That means I'm giving all the keys to it for it to search and give me the data. So here is the data. Okay. But my key, what is the key I'm expecting for my get? Pure get, it requires the account number as well as the customer ID. and customer name is not what I'm looking for. So it does not require. So I'm taking this and I'm invoking get with this data. So when you are invoking the smart contract, you can see whatever the return value from the get, you can see that it has given the ABC. It has given only one record because I have invoked the get, which requires both account number and customer ID, and it's both are part of my complex key. And I'm doing a definitive search and I got the exact hit of it. Now I want all the details mapped to a particular customer ID, all the accounts I want. So I'm going for get all invocation to check what exactly I have on my ledger mapped to this customer ID. So this get all. So what I do is my customer ID is 123. This is a split key. So I am just doing that. So I'm invoking this. So now I should be getting all the records. So you can see here, I got this much of data. See, 1, 2, 3, 4. I have got 1, 2, 3, 4 account, and then I have got 3, 4, 5 account as well as 6, 7, 5 account. 3 gets have been mapped to the customer 1, 2, 3, and I am doing the partial key search, and I gave till the customer ID. What I just gave customer ID and I got all the keys mapped with this and this. So if you are using Couch, you can do the all the selector operations you do on your keys or on your column names, all the fields, attribute names, in all those search things you can do. If you are all complex key searches, you can perform if you are using Couch. But given that it is a level D, which is a plain key value mapped thing, so you should be able to like the way how you access should, as per the business logic, you should frame your keys such a way that the efficiency is better. But compared to this, it is pretty much fast compared to Couch. You can go for level DB or Couch DB based on your business requirement and based on the response, how fast you need. You can go choose this one. Yeah, so this is about the smart contracts, like how you can write a smart contract, how you can install, instantiate it, and how good you can write your keys. Any questions still here?
All right, Sai, let's cover the last couple of slides, right?
Okay, Akshat, so um, any questions till now, or shall we take through the efficient way of handling the smart contracts?
I see one hand going up.
Uh-huh.
No, I don't see it now.
Any questions? Can you please type in the chat box?
Okay, so so this is pretty much what Sai covered, right? The fabric ledger, what happens, what happens in the transactions and all those things. We have one last agenda for today, right? Which is the common issues that we see, right? Right. So the second one that you see, the efficient way of designing keys. This is what TiE covered, right? So the keys that you create are always should always be progressive keys, right? And it should be it should not be too long because they take the ledger space. They should be meaningful, and they should be in such a way that they could be used as partial keys as well, right? So uh, I mean, we should avoid creating, I mean, many keys, right? We should create keys in such a way that we can do some complex, filtering and sorting and all those things, right? MVCC is an interesting topic. We'll take it up at the last, right? Uh, Peer execution timeouts are seen when there's a request from the app layer and the peer does not reply uh, in within a certain period of time, right? So either the peer times out, that means the chain code. So there's a certain timeout at the peer level, right? So it might be possible that your smart contract is still calculating, computing, doing the transactions, but the peer terminates the request, right? It times out, and your application will then get a timeout, right? That is one of the problems that we see. Out of memory issue on peers, right? Uh, it is possible that you are doing some bulk computations, you are doing bulk retrievals, or you are doing bulk deletes. So anything that comes in bulk, or which might take, so you let's say you do a query, right? You do a partial key query, right? And you get a bunch of data from the ledger, right? And you have to sort them or compute them or do some uh, transactions on those results, right? So all that result set will occupy some space on your peer, right? And because there might be concurrent requests that you get on the peer, your peer might run out of memory, right? So that is one other problem that we have seen. Handling peer lags, right? So there might be cases where you do a transaction. See, transaction always happen on a peer, right? And depending on your endorsement policy, it gets propagated via order to rest of the peers on that particular channel. So it might be possible that you do a transaction on peer one, and concurrently there's another request for getting the result of the transaction on peer 2, right? So there might be, it is possible that that particular transaction has not even reached peer 2, which you are using to query, right? So there's a peer lag, right? So a peer 1 could be at block height 40, whereas peer 2 might be at a block height 35, right? So it is behind peer 1. So in that case, some of your transaction might fail because it would say that I don't have the result, or I don't have the transaction. And you would feel that the transaction has not happened, whereas it has happened and it has not reached peer 2, right? uh, MVCC, right? MVCC is a very common problem, the multi-version concurrency control, right? It is not just for any of these are not specific to blockchain, but it would happen at other places with other technologies as well, right? So uh, it would happen that the read or the write for the same index, right, happens at the same time, right? And there's a version concurrency fault there, right? So this is a very common problem that we see, especially when you have uh, asynchronous calls happening every time, right? So a network can be a huge network. There could be, hundreds of requests coming in per second, kind of there could be a scenario, and you might encounter MVCCs frequently, right? So we have seen, so these are very common things that you see, right? And there's some tips that we can, that you can use, that we have used in the past. Sai, would you discuss them? Does anybody hear me?
Yeah. Yeah, thanks, Akshat. Yeah, I'll take these issues from the smart contract perspective, how you can handle this in the code. Okay. So MVCC, multi-version control, concurrency control. This, if you see it as Akshat has explained, it does exist everywhere. So there are two things, right? Locking, or you have to do the version control. So locking in the sense, what is general way of locking? Until I complete my transaction, until I complete the transaction of a particular isolated critical block, critical section, until I complete this, no one can come and disturb me. Is the one way of taking the transaction as an atomic one. That is nothing but it is a locking manner. And the other way is version controlling. That means to say like cloudent, how the cloudent works. Suppose 100 writes are happening and reads are happening. So the what the cloudent does is in a decentralized manner, and if it is happening for that particular write, all the reads will be seeing the recent particular data, but it will not be locked. It will not be locked for any reads. Cloudent cannot will not block it. So that's the reason why when you are performing in a Cloudent, right, sometimes you will get to see the stale data. So from smart contract is also nothing but it is writing to the ledger. Here there is a cloud. Here it is the fabric ledger, right? So ledger is also nothing but a sort of a database. So here also the same. There also you have the rows and where each will have the key index. Here also you have the keys. So when you are particularly acting on a key and you cannot allow another request to come and modify this same key. Okay. So two ways. Either you do the locking, that means until and unless you complete your transaction, you cannot make the application to make another request, or you don't expose any of your transaction particulars, a transaction variables, whatever you have, right? You have got the transaction, like when I say like get state, I got the account details object, and I should not make this account details to be available at the instance level of my smart contract, because it will be shared across the threads, and the other thread which is coming in may see the different account details object altogether than what is there on the ledger. So it will get to see the stale data, or it will try to act on the stale data, which will cause the MVCC conflict in case of fabric. So second thing, efficient way of designing keys. I explained it through the code itself. And third one, he already explained peer execution timeouts. So sometimes what happens, right? There are cases like where you will be making recursive calls, or where you will be making calls to other smart contracts and getting to some data. So always write a way, always design your like architecture such a way that you will get all the details required for you in like particular account or a particular thing in a one place. Rather than making hundreds of smart contracts, means hundreds of chain code to chain code calls and getting each detail from every place, ultimately it will go and execute. And don't do infinite looping in your code. While true, get all the details. This again comes into when you have a thousands of data, and as I have shown you, right, get partial key searches. You should be careful with this. Get partial key searches. Suppose I have my customers, I have only three keys mapped to that, so it has shown me. My ID has only three accounts. It shows. What if I have thousands of accounts mapped to a particular ID. Then I will be getting all 1,000 into I have to get all the 1,000. I have to iterate to find out a particular account of particular type is there or not. Correct. So instead, I should design my key such a way that it should have a account type part of the complex key so that I can do partial key search with that account type. So such things will reduce the chances of having the pair execution timeout. So effective way of modeling your data will help you out in not getting into this peer execution timeouts. And out of memory issues on the peers, like I said, if you are not, this is also interlinked. If you have not properly designed your keys, then what happens? 1,000 accounts are mapped to a customer ID. I have to dump all the 1,000. I have to query back from my ledger and dump into my heap memory, and where I may not have sufficient resources to handle all those and may eventually end up in out of memory. So either in these cases, when you can't avoid that, you have to, where and when possible, you have to go for the pagination. So pagination is nothing but retrieving only set of documents of particular size to your heap. That means I mean to say, like, if I my pagination size is 100, 1 to 100 only I will be page size is 100, only 100 at once I will be taking that and serving my request. But even before going to that is we have to go through our models and design our keys such a way that we will not end up in such a situation. And third one, like the last one, handling peer lag issues, which already he explained. Like one pair may not receive the recent data. In this case, how we can handle this? These cases will generally be handled from the applications or the caller's end. So the caller should decide whether I should see, query is also making a query call, right? Querying any one of the peer for getting the data. So instead, the application have all the liberty to make a query proposal to every peer in the network. So it can get the proposal responses, compare it. If it sees there is a discrepancy, that one pair response is not as same as the other one, it can wait and it can make a query again to see if it is getting the consensus response from everything. That is one way. Or you can do, if you are like some of the applications would prefer than comparing these proposals, what they would go for is generally they make a query to a pair, and if it is if they are certain that the response should be there and it is coming as not there, in that case they will wait for some time and make a query again to the pair with a retry and will improve their resiliency. One of the approaches you can follow, either you query all the pairs, compare your responses, or wait for the some time to improve the resiliency, sleep for some time and retry again to the peer getting the query and address it. So these are the two things. And one more thing, when you are especially using level DB is so because these keys, basically I have shown you the key, right? So it is a complex keys you will be forming. So these are basically string kind of things, right? So you know how the strings behave with the numbers. So string 1 and string 10111, these are all like these will fall in place. If you say ascending, if you say string 1 will come, string 111, next 1111. So it will be taking in the lexical order of that. It won't know that 1 is a digit and after 1 it should come like 11, then 12, then it should go for 20, then it should go for 100. It doesn't know. It all goes with the lexical ordering of the strings. So 1 1 1 1 and then 1 1 1, it goes like that. So you will not have a order done. So if you want to maintain any order in the keys, always do the 64-digit padding for your versionings or the any digits which you want to incorporate as part of the key, so that you will get the perfect ordering, or you can do all kinds of paginations or sorting or anything based on that. Okay, so that's all these are some of the common issues, and that's all I have for the day. Akshat, over to you.
Okay, so I think we are at the end of the session. We would if there are some questions, we would be happy to answer them for you. Okay.
I
I
think Akshay, they don't have the access to unmute to ask questions and all. They should use only the chat box. Or if
Yeah, maybe you
Devjani has
can.
any other way, she can.
Yeah, if you guys, anybody, if you have any question, you can raise your hand. I can probably unmute. Okay, I don't see anything in the chat and nobody is raising any hands. I think we will close now. Uh, Devjani, I think we are done, and we can close the call now.